variables on both sides. So kind of taking our two-step equations, going a little further. These will be some 3, some 4 steps in these. So either way, we're trying to get the variable by itself. That's our job. That's the only thing we're really after here. So when you're solving equations with variables on both sides, the name of the game is get the variable to one side, the numbers to the other. It does not matter mathematically which ones you move first. Okay, I tend to try to get the variables together first and then get the numbers. That's just my style. That doesn't mean you can't move the regular numbers first or change it depending on the problem. Okay, it doesn't matter to me which one you do first, as long as the operation you're doing is legal, then you're good. Okay, so since it's an equation, whatever you do to one side has to be done to the other, just like it's been the whole time that we've been talking about equations. So let's start with this one. We got negative 14 minus 6x equals 6x minus 2. So we've got a, x's on both sides, numbers on both sides that don't have a variable. So we want to try to get those together. So I'm going to move the x's together first. Okay. Come in, have a seat. Join us. All right. So I'm going to add 6x here. Why am I adding 6x to this one? Because they're minus, and it's going to cancel it out. That's what we want to happen. So if I add 6x to this, where do I add 6x on the other side? To the 6x, because they're what kind of terms? They're like terms, meaning they got the same variable on them, okay? So on this side, the 6x's cancel out, but on the right-hand side, 6x plus 6x is 12x. Still got the minus 2. On the left side, all we got left is negative 14. Now it's a two-step equation like we were doing last week. So which one of these needs to move? That minus 2. So how do we move it? Add 2. That's good. That cancels out. Negative 14 plus 2 would be negative 12. Good job. One last step. Divide by what? 12. That number that's in front of x, divide by it. That cancels it out. Negative 1. Don't forget the sign, because it's negative 12 divided by positive 12, so it's negative 1. But good job. All right, so that's our job today. Get x by itself, get all the x's to one side, all the numbers to the other. If you like putting the x's on the left, then you can do that on every problem. I don't care. Doesn't matter to me. If it doesn't bother you that they're on the right-hand side, then leave them on the right-hand side. That's fine. Okay. Look at example B here. So we had x plus 3 was negative 1 plus 2x. Well, that first one, we moved the x's first. Again, that doesn't have to be what we do. We can go the other direction if you wanted to. So let's say we wanted to move this 3 first. So I would minus them, right? Yeah. So subtract 3. What do I subtract 3 from on the other side? That negative 1, because they're like terms again. And there's x equals, what's negative 1 minus negative 4? Good job. Plus 2x. Now, which side has too much stuff on it? The right side. So what needs to move? Which one is like this one? The 2x, right? How do we move that 2x? Yeah, subtract it because they're adding. Careful. 1 minus 2. Be negative 1x, right? Be careful on your signs there. Anytime there's just a plain x, it's a 1 in front of that. Remember, that's there. And then, how do we get divide by what? Negative 1. Yeah, that negative 1 that's in there. And then that's going to give us x equals positive or negative 4? Why positive? Signs are the same. Signs are the same, and you're either multiplying or dividing. The answer's going to be positive. Okay. Good job. Not bad at all. Negative 6a minus 1 equals 3 minus 8a. See if you can do this one on your own. If you can get started with it. I'll kind of give you a little bit of time, and then I'll start putting a step-by-step up there. You can check your step. See if you can get started with it. About 4 different ways to start that problem. Right. You got the right answer for your A part, but the 3 still. This is a minus 6 operation. Plus negative 8 plus 6. Yeah, you brought that down, that's right. You brought the 3 down, that's right. Now it's a minus 8. So I treat it as yeah, you do that like that. Right? Negative 6 plus 8. Yeah, do that. Do that. Good. Several different ways of starting this problem. Here are the legal ways to have started it. I saw some folks doing this. If you added 6a, that's legal. Raise your hand if you added 6a for your first step. Okay, saw some folks that had done that. That's good. Not the only thing that you could do. If you wanted to add 1 to both sides, that's legal too. So that works just as well. Another first step you could have done is adding 8a to both sides. Anybody do that? That's the less likely one because it's the furthest one on the right. You did that? That's good. That's good. It still works. Okay. The only other option would have been subtracting 3. Did anybody do that one? That's like the least likely one to happen for most of us. Some of you never raised your hand at all, so I'm assuming you didn't do anything. So I'm going to add 6a. That gives me negative 1, 3, and then what's negative 8 plus 6? It's negative 2a. Okay. What would be the next legal step for this way? I don't want to do that because which side has too much stuff? The right side. So I need to get rid of this 3 here because it's like that. So I'm going to do what with it? Subtract because it's a positive 3. That minus sign that's right there goes with the 2a. So if I subtract 3, that cancels it out. And then what's negative 1 minus 3?
Negative 4.
Good job. Is it negative or positive?
Negative.
Negative because it's negative 1. It's like I owe you $1 and then I borrowed 3 more, so I owe you $4 now. Last step. Divide by -2. If you did everything correctly and legally, mathematically, your answer should be +2. If you arrived at that, then your steps were legal and you did them correctly, okay? Like I said, there were 4 different ways to start the problem, which would have changed everybody's second step if you did it a different way, which is, it's fine. Just got to make sure you're doing legal steps, okay? All right, let's look at this kind. So we had 13 plus n equals 1 plus 3n plus n. So we got a little bit more in it. We're just kind of steadily increasing our difficulty here. Now, when I see a problem like this that looks really long, I always try to make it a little easier and simplify it a little bit. Is there a way to simplify one of those sides? Okay. I can put the ends together. On this side right here, there's 2 places where there's ends, and we can put those together, and it would make how much? 4n. That's what I would do. That would be my first step. Is to put these 2 together because they're like terms. We have a +3n plus a 1n, and that's how we end up with 4n. Okay, so putting the like terms together that are already on the same side. If they're on the same side, you don't change the sign. Okay, I didn't subtract 1n. I just left it there, and I said, oh, that's a +3 plus a +1. That's how I get 4. If they're on the same side, use the same sign. Okay, same side, same sign. Now, the next step is to get letters to one side, numbers to the other. Okay. What if I wanted to move this 4n? How would I move it? I could subtract it, right? Because they're plus, we got a plus sign there. So if I subtract 4n from 1n, what do I get? 1 minus 4.
Oh. 3.
-3. -3 because it's +1 and a -4, so that makes a -3. All right. It's like you owed me $4 and you gave me a $1 payment. Now you only owe me $3. That's -3. Okay. Now, what's the next step for this problem from here? Subtracting 13. The reason we want to do that is this side's got too much stuff on it. So we want to move the like term that goes with that 1, and that's the 13. So we're going to subtract 1 minus 13. -12. Good job. Now what? Divide by that -3 that's in front of the variable. What's n? Positive or -4? +4. Okay. How do I know that's correct? And talk about this on the first 3, but how do I know that's correct? How could I tell if that's correct? Plug it into the original problem. Make sure both sides end up being the same. If they do, then you got the right answer. If they don't, then you might want to go back and recheck. Not a might, you do want to go back and recheck. What are we on? E? All right. All right, here we go. X minus 8, real simple, left-hand side. Right-hand side is 8 plus 5x plus 2 minus 7x. Ooh, a lot of stuff on the right-hand side of this one. So let's make it smaller. How can we make that smaller? Yeah, that 8 and that 2, they're like terms on that side. So and it's +8 and +2, so we put them together. That's 10. Okay. What else could we do on this side? We've already used these 2, so those go together and make what? +5 and a -7. What's 5 minus 7? Negative 2x. Has anything happened to the left side? No. I'm just going to copy it down. Okay. So now we've taken the longest problem Hunter's ever seen and made it not so long anymore. Okay. Now what? Add 2x. That's a good move. What are we going to add 2x to? To the x on the other side. X plus 2x is 3x minus 8 equals 10. Now we're finally to a two-step equation like we did last week. What's the next step on this problem? Move that 8. So we're going to plus it. Add 8. That's right. Good job. 18. We're not done yet. We got to divide by 3. X is 6. Again, showing every step. We're putting things together, moving things from side to side. We got to show those steps. Let's get this one. 15 minus 7x minus x equals 6x plus x. Ooh, this one's a lot of x's in it. Oh, my x's. See if you can do this one. Get started with it. See if you can get started with it. All right. Can we do anything on the left side? Yeah. We got some like terms, don't we? We got a negative 7x and a negative x. Together, that would be negative 8x. So that'd be 15 minus 8x. What about the right side? That one's a little more logical. It'd be 6x plus 1x is 7x. Oh, that shortened up quite a bit there. Now what? Add 8x. Why are we adding 8x and not moving the 7x? Which side has too much stuff? This side. So that's how you know. A lot of folks will get confused because you'll move the wrong thing, okay? Look at the side that has too much stuff and move from it. So we're going to add 8x. All right. So we're adding 8x to both sides. There's 15 is equal to 15x. One more step. Divide. X equals positive 1. All right. Let's look at this one. Let's say we had 16 minus 3x equals 14 minus 3x. Go back to a little easier problem, maybe. Shorter. I don't know if it's easier or not, but shorter. What would our first step be, or a first step be? If we add 3x to both sides, that'll move one. But what happens when I do that? What happens to this 3x and this minus 3x and this plus 3x here? They cancel out, right? What happens over here? Oh, man. Yeah, they cancel each other out, and there's no x's left. Does 16 equal 14? Ever? No, never does that. So this is false. Anytime that's false and all the variables have canceled out, that's a special case. That's a no solution problem. Okay? So if all your variables cancel out, you look at what's left. If it's false, it's no solution. Okay? If it has 7 equals 0 or 16 equals 14 or negative 2 is equal to 18, anything that's not true, it's a no solution. You look at the numbers. If they're not the same number on each side, then you know it's not true. Because 16 is never equal to 14. It has to be the exact same numbers on each side. Let's say we had this 3 plus 5x plus 2 equals 2x plus 5 plus 3x. Maybe something like that. Back to a tougher problem. Well, longer. It's not really that much harder. What can we do on the left side of this one? The 3 and the 2 are like terms. We can put them together. So 3 plus 2 is 5. So we got 5x plus 5. What happens on the other side? Yeah, put those two together and get 5x plus 5. Now if I try to get my x's together, minus 5x, what happens to them? They cancel out. Does 5 equal 5? That's true. Anytime it's true and all the variables have canceled out, it's all real numbers. So when you're solving these, if there's a letter left, you got an answer. Okay? If the letters all cancel out, you're either got no solution or all real numbers. Okay? No solution if it's false, all real numbers if it's true. Okay? All the letters have to cancel out for those two cases to happen. Okay? They don't happen a ton. So when you're working practice for this, you're not going to see a no solution in all real numbers like every other problem. It's just going to be one or two out of a whole set that you would see that happening with. Okay? All right. Let's do a decimal problem. Because we've done integers is all we've done. So let's do a decimal problem. Say we have 0.2n plus 3.8n, minus 3.56 equals 1 plus 3.2n. So, same idea, we just got decimals now instead of just integers. Okay. What's the first thing we should do? Put the like terms together, right? 0.2n and 3.8n they're the same kind of thing, right? They both got n, so put them together. $3.80 plus 20 cents. $4, right? 4n minus 3.56. 1 plus 3.2n. Okay. What is a legal move to do next? All right, I heard two answers. I heard you could subtract 3.2n or you could add 3.56 to the 1. Either way works just fine. I'm going to add the 3.56. Just and there's 4n, 4.56 plus 3.2n. Now, what's the only thing I can do that's legal? Which one am I moving? How? Go ahead, Hayden, say why. Yeah, the one on the right side's got more stuff on it, so we want to get rid of that person. So we're going to subtract it. And Caitlin had said that that was what she wanted to do to begin with. And she may have done that, and it's okay. What's $4 minus $3.20? Yeah, 80 cents. All right. One last step. We've got this one solved. Divide. Yeah, divide by the 0.8. And how many times does that go into that? 8 goes into 45. 5 times. 5 left over, 5.7. And again, how do you check that? Plug it into the original problem, make sure it works. Okay? So there's us a decimal problem. Work is all the same. We're just dealing with decimals instead of integers. All the work is the same. Guess what's next? Yeah, everybody's favorite. If you get it right. Can you get it right? I'll be easy on you. I'll do it an easy one. N minus 5 over 4 equals negative 1/2 n plus 1. So an easy one. Well, it's not the easiest, but it's an easy one. We did those 2 weeks ago. Yeah. We were doing one steps. Those are the easiest ones. All right. So again, there are several ways to start this. What's one good way? Okay. Adding 5 over 4 to what? To both sides, and adding to which piece over here? To the 1, because it's what kind of term? It's a regular number. Okay. This is a fraction. Is 1 a fraction?
Yeah.
Can it be? How do we write 1 as a fraction? Put it over 1, yeah. So that usually helps. And remember, when we add fractions, we got to show that work that we're getting what the same. The denominator's the same. So the left side's n, got negative 1/2 n. And then what's the denominator that we should use for those two? 4. So how do we turn the 1 over 1 into something over 4? Yeah, multiply it by 4 on top and bottom. So that's 4 over 4. 4 over 4 plus 5 over 4 is 9 over 4. Good job. Now what? Add the 1/2 n. What's in front of this n on the left? Well, 1. So there's that 1 again. And 1 plus 1/2, well, that's really 2 over 2 plus 1/2, which is 3 over 2 n. 9 over 4. Here's that last step. Logan, you got to, if you want this to be the only fraction problem you do, you got to tell me. No help from anybody else. Tell me what we do to get n by itself. By what? Okay, and dividing by 3 over 2 is the same as multiplying by the reciprocal. That's right. Good job. All right. What's the reciprocal? We'll help Logan out for that. What's the reciprocal of 3 over 2? 2 over 3. So we're multiplying by the reciprocal, 2 over 3. All right. 3's cancel, 2's cancel. There it leaves us in. That's what we want. Can we cross cancel with 9 over 4 and 2/3? Yeah. The 9 and the 3. 3 and 1. 2 is 1 and the 4 is a 2. So that ends up being 3 times 1 is 3. 2 times 1 is 2. 3 over 2. Final result. All the work is the same. You're just dealing with different kinds of numbers as you go along, okay? So make sure that you're getting your like terms. Look for like terms on each side. Put those together first. Then get your variable to one side. It doesn't matter which side. Get your regular numbers to the other, and then you've got your answers, okay? That's the job, okay? Khan Academy, you've already got, there are 3 assignments there that encompass solving variable on both side equations with integers, fractions, and decimals, and then one that talks about the no solution and all real numbers solution stuff, okay? So working on that stuff.